Hey, OChemsters, this is Mrs. Vandalay bringing you the alcohol ether nomenclature review, last thing of the chapter worksheet. All right, so it actually had nomenclature, but there's also some reactions on the back page. So my hope is that you have already gone through all the videos, you've done the other two practice worksheets that were in this chapter, and so this is the last kind of recap. So I hope you've done this worksheet and now you're just checking your answers. If you have any questions over that, don't hesitate to email me. I'd be happy to help you out, okay? So let's go through this. Number one, we're going to name this. It's actually an alcohol. I think you can tell that. So I numbered it. So the alcohol is on the 2 and the methanol is on the 2, or the methyl is on the 2. So I called it, I can do like this, 2-methyl, 2-pentanol. It's probably the more common way to say it, but this isn't necessarily wrong either. 2-methylpentan, 2-all. All right. Now, letter B is an ether. You just finished up your ether discussion. So not too long ago, you learned how to name this. So let's see here. There's no branches, so I need to figure out what comes first. So I have a propyl and a hexyl group. Well, hexyl comes first alphabetically, so it becomes a hexylpropyl ether. Now, as we're going to see, if there was a branch, we would name it differently. We would need something oxy, but if it's no branches, it's a hexylpropyl ether. Okay, let's look down at letter C. All right, so this is another alcohol, and it's a cycloalcohol. So I'm going to number it. Notice I made the alcohol the first carbon. Okay, you remember that. So this becomes a 3-bromocyclopentanol. If you only have the one alcohol in it, it has to be on the first carbon. Now this is also another ether, but it's a branched ether. Well, sort of is a branched ether. This is actually a cyclobutyl. So I need to kind of figure out what comes first. I have the butyl first, so it's a cyclobutyl methyl ether. All right, so sorry, that is not a branched one. Let's keep going. All right, so when you're looking at this, what do you notice? I see an ether group here. I see an alcohol here. The priority is definitely the alcohol, but it's not just any alcohol. What do you recognize that as? Do you recognize it as a big 9? And the answer is you should. All right, so I need to make my alcohol carbon number 1. And so on carbon number 4 is my branch. So I do have a branch here. So it becomes 4-ethoxy. Why F? Because I have 2 carbons here. So it's on carbon number 4. So it's 4-ethoxy phenol. Now, what about this next one? All right, do you recognize this or this? Which one? This is a big 9, and this is a big 9. So this is a benzaldehyde, and this is a phenol. What takes priority, the benzaldehyde or the phenol? Do you remember when we were talking about phenols, all right, or the priorities? The aldehyde ketones and carboxylic acids will take priority. So I have to recognize this first, okay? And then how do I name it? All right, well, I have to, number it, of course, because now my benzaldehyde takes the priority. So I have a alcohol group on the 3rd carbon and an ether group on this one. So I have a 3-hydroxy, H comes first, 4-methoxy benzaldehyde. All right, so we have a hydroxy and a methoxy, and then the benzaldehyde takes the priority. So in part number 2, we need to draw. So why don't we do those? So I have a 1,3-butadiene, which I have right here. And on number 2, I have a hydroxy, and on number 3, I have a methyl. So there you go. The next one is pretty straightforward. It's a methylpropyl ether. Okay, let's go to the next page. All right, I have a 2,4-dihydroxy benzoic acid. So remember, benzoic acid was another one of those things that took priority. So here's my benzene ring. So it's benz, but now I need to make a benzoic acid. So I'm going to put that here. So that's my benzoic acid. So this must be carbon number 1. So, whoops, I'm sorry about that. Carbon number 2 will be here. all right, and then carbon number 4 will be there. Finally, we have a 3-propoxy. So this is going to be a branch, 2,3-dimethyl hexane. So here is my hexane, here is my 2,3-dimethyl, and here's my 3-propoxy. Okay, so now we come to our mechanism, or excuse me, our reaction. So let's look at these. It says write the products for the following reactions. If one or more product is possible, write out both and circle the one that occurs in greater quantity. All right, so do you remember the saying that goes with this? If you what? If you can make water, you will make water. So when you see the heat, think of elimination. We're going to actually get rid of the OH, and so we're going to have a double bond. Well, where are my beta hydrogens? I do have a beta hydrogen here. This is a tertiary. There is still a fourth bond, which is a hydrogen. And then there's going to be another beta hydrogen off of here. Okay, so I'm going to have this. That's when I'm using the hydrogen on that carbon. And what else? I'm going to have this, and that's when I'm using this beta, excuse me, this alpha hydrogen, no, it's a beta, this beta hydrogen over here. And then I'm going to get water. So now the question is, which one is going to be in greater quantity? It's the one that's the most substituted. Well, what does that mean? It's the fewest hydrogens off the double bond. So how many hydrogens are on this carbon? It has 1, 2, 3, 4 bonds already, so there's none. And how many hydrogens are here? It has 1, 2, 3, it has 1. So there's none and 1. Well, how many are here? We got 1 and 1. So this is the more substituted group. So this is going to be the one that is a greater quantity. Now the next one is pretty straightforward. It's just a simple substitution. So if you can make water, here you will make water. So the OH goes off with the H to make H2O, and then the chlorine hops on. All right, so how would I name that? It looks like you have a 1-chloro-2-methyl cyclobutane. Okay, let's look at the next one. So I have a 1,2,3 trihydroxypropane. And remember when we do it this way, I usually write it in a little bit different way. And why would I do that? So I can really see if you can make water, you will make water, okay? So I kind of showed you where the water is coming from. And here I make this, so the OH and the H falls off, but what's right attached to the H here is another oxygen, and then I get 3 waters, okay? So I have plenty of nitric acid to do that with. What about this next one, all right? So I see this plus heat again. So I'm thinking, what kind of reaction? I'm thinking of elimination. So here is my numbering. I didn't redraw it with a crook in it. I drew it kind of straight line there. So where could my my beta hydrogens show up? I could have one on 1, or I could have one on 3. So if I have it on 3, I don't know why I went with that one first, but there is that. What about if I want it on 1? All right, where would that one go? It would be right here. Okay, and then of course I get water too, don't I? So now the question is, well, which one is more substituted? That's going to be the one that I'm going to have more of, right? So how many hydrogens are on this one? Well, how many bonds does this carbon have? 1, 2, 3, 4. It has none, and this has 1. So together there's only 1 hydrogen off the double bond. Over here I have 2 and none. So which do I have more of? I have more on this one. I have 2 versus 1. So this is my more substituted. This is going to be your more common. And again, why is that? It all goes back to the stability of the carbocation, if you remember that. Okay. So now let's make some ethers. Sounds like fun. This is write the equation of an ether using 1 butanol and 1 methanol. So here's my 1 butanol and here's my 1 methanol. All right, again, why am I showing you this way? So that I can show you if you can make water, you will make water. So I'm going to make water, and then the O and the C come together. All right, and there I go. And how am I going to name this? Well, this is a B for butyl. This is an M for methyl, so it's a butyl methyl ether. Let's look at the next one. All right, so write an equation of an ether using 2-propanol and 1-ethanol. Name the product. All right, well, here's my 2-propanol. Mrs. Vandal, why'd you draw it that way? Well, you'll see. All right, and then here's my 1-ethanol. And once again, what is my favorite saying? In this case, if you, what? If you can make water, you will. That's why I drew it that way. So if you can make water, you will make water, right? So I'm going to make some water. And so the OH and the H, comes together. So this O is going to go on the second carbon. So how are you going to name it? Well, this is a branch, isn't it? So it becomes a 2-ethoxypropane. And there you go. Well, I hope that helped you. I hope you're feeling a little more confident with alcohols and ethers and their reactions. So that's the end of chapter 7 and 8. Don't wait to be great. We'll see you next time. Bye-bye.